We will now continue our discussion of 6.3, where we will discuss the idea of a reference angle. Let's begin with the definition. Our definition says, given an angle theta in standard position, the reference angle, theta prime, associated with it is the angle formed by the x-axis and the terminal side of theta. Reference angles are always greater than or equal to 0 and less than or equal to pi over 2 radians. So as we look at this definition, there are two things that we want to be sure that we understand. First of all, the reference angle is formed by the x-axis and the terminal side of your angle. The other thing that we want to keep in mind is that reference angles have to be between 0 and pi over 2, which means that the reference angle must be an acute angle, an angle less than 90 degrees. So let's look at a few examples of finding reference angles. Our example says, determine the reference angle associated with each of the following angles. We're going to do several examples here. We're going to start with an angle of 120 degrees. Now, if you remember in our last section, this is the angle that we looked at, and we drew a triangle and used the triangle to determine the point so that we could identify the trig functions. And we talked about there might be an easier way to approach this. The easier way to approach it is to use a reference angle. So we're going to begin with that idea and then expand on it a little later during this session. So to begin, to find your reference angle, what you want to first do is you want to draw the angle that you're given. So if our angle is 120 degrees, we want to sketch out that angle. Now we'll use what we've learned about the position of these angles on the unit circle to identify where that angle is. Remember that as we count in degrees, remember that we have a 30-degree angle, a 60-degree angle, and a 90-degree angle. And then the next one would be, the next multiple of 30 would be 120. So our 120 is going to sit right about here. Now, the definition of the reference angle said that the reference angle lies in between the terminal side of the angle, which is here, and the x-axis. Remember that your x-axis is this horizontal axis. So your reference angle is going to be in between the x-axis and the terminal side of the angle. And so your reference angle is going to lie right here. Now, your other option is to look at your reference angle being from the terminal side of the angle back to this x-axis. But remember that our definition for the reference angle indicates that the angle has to be less than 90 degrees. And since this angle is more than 90 degrees, it will not work as a reference angle. And so what is our reference angle? Well, we know that if we were to start in standard position and rotate all the way across over here, we would be at 180 degrees. So our reference angle is the difference between 180 degrees and 120 degrees. So our reference angle is going to be 60 degrees. Okay, so let's try another example. So what if our angle was 210 degrees? So again, we'll start by drawing out an angle that has a measurement of 210 degrees. The angle needs to start in standard position. Remember that we count using multiples of 30. So we have a 30-degree angle, we have a 60-degree angle, we have a 90-degree angle, we have 120, 150, 180. Coming on around 210 is going to be right here. All right, so once we know where our angle is, we need to think about where the reference angle lies. Remember that your reference angle is going to be in between your terminal side of the angle, which will be here, and basically your closest x-axis. And so if this is your terminal side of the angle, the fastest way to get to the x-axis is to back up here. And so that blue arrow is going to represent your reference angle. And what is the measurement of that angle? Well, if our original angle is 210, and we know that this straight across line is 180, then the reference angle is going to be the difference between the two. And so for us, 180 or 210 minus 180 is going to give me a reference angle of 30 degrees. All right, let's try another one. What if our angle was 315 degrees? And so again, we'll start by sketching out a picture of the angle. 315 degrees is a multiple of 45. And so remember how we do those. We will mark off the diagonal, that's 45, and then straight up is 90. Coming here is 135, straight across is 180. Then we have 225, 270, and the next one will be 315. All right, so once we get our angle drawn, we can look at where that reference angle will be. Again, the definition of the reference angle is the angle between the terminal side of the angle, which is here, and the closest x-axis. So our options are to rotate up or rotate back. The closest one is going to be rotating up. All right, so our reference angle is the angle here in blue. What is the measurement of that reference angle? Well, we know that we're at 315 right here. If we continue to rotate back up to the beginning line, we would be at 360. So 360 minus 315 is going to give me a reference angle of 45 degrees. Now, we can also look at reference angles in terms of radians, which I did not do in my example. So we're going to do one radian example. So let's do that real quick. So what if our angle was 4 pi over 3? All right, so again, we're going to start by drawing the angle. You could convert 4 pi over 3 into degrees if that makes it easier to draw. Or you could look at remembering that when we were talking about the angles in terms of radians, we used multiples of pi over 6. So 4 pi over 3, what I'm going to do is take it, 4 pi over 3 is reduced. I'm going to take it back to the unreduced version of the formula. All right, so that would be 8 pi over 6. Remember that when we counted these out, we counted them out as multiples of pi over 6. And 8 over 6 is the same thing as 4 over 3. And that's just going to help me count it a little bit easier. All right, so here's pi over 6. Here's 2 pi over 6. There's 3 pi over 6. 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. Here's 8 pi over 6. All right, so once we get our angle drawn, then we have to determine what our reference angle is going to be. Again, our definition for our reference angle says that we will go from the terminal side of the angle to the closest x-axis. So we can either go up or we can go back to the right. Closest way to do it would be to go up. So our reference angle lies here. And what is the measurement? Okay, so let's see. This is, we know 8 pi over 6. Remember that straight across was 6 pi over 6. And so the difference between 8 pi over 6 and 6 pi over 6 would be 2 pi over 6. And 2 pi over 6 is going to reduce to pi over 3. So our reference angle will be pi over 3. Now, I wanted to show you 2 other examples that the book has. Because they are a little bit different. All right, so let's make part E, and let's say that our angle is going to be 9 pi over 8. Now, we need to draw 9 pi over 8, and we have a couple of options here. One of those options, again, is to convert it to degrees and use that to help us identify where the angle lies. The other option we have is to realize that if we're counting by fractions over 8, that this line right here, which we know to be pi, coming around this way, stopping here, we know that that's pi. In terms of a fraction with an 8 as the denominator, that fraction would have been 8 pi over 8. And so if that is 8 pi over 8 and our angle is 9 pi over 8, we know that we're basically just a little bit further along. Now, I don't know exactly where that angle is, but I do know that it's not far from the 8 pi over 8. So I'm going to go ahead and just estimate that this is 9 pi over 8. Now, where's your reference angle? Your reference angle is going to go from the terminal side to the closest x-axis. So your reference angle is going to lie right in here. And what's your difference between 9 pi over 8 and 8 pi over 8? So that would mean that your reference angle is going to be pi over 8 when we subtract. Okay, so know that sometimes you'll have examples where the angle is not something on your unit circle and you have to do a little estimation. Know that you can always convert to degrees if you get stuck and you need to identify where that angle lies. All right, and then the last one that we're going to look at is negative 655 degrees. So this one has a couple of things that we haven't seen. First of all, we have a negative angle, so we haven't done one like that. And this one is also bigger than 360. So let's look at what happens when we draw this angle out. All right, so we are rotating down instead of up because of the negative. If I rotate all the way around, remember that I've gone 360 degrees. So right now I'm going to say, all right, 655 minus 360. And let's see how much of an angle we have left. So we have 295 degrees left. All right, so I'm going to keep rotating. I know that if I rotate from here all the way up to that, I've accomplished 270 degrees. And so that would leave me 25 degrees left to continue. All right, and so I'm going to estimate just a little bit, and then I'm going to say, okay, so here is my angle. And so this will be the angle that's negative 655 degrees. Now let's look at the reference angle. The reference angle is going to run from the terminal side of the angle to the closest x-axis. So the reference angle is going to be this remaining piece here. Well, what is that angle? Remember that this part was an additional 25 degrees right in here. So we know that the entire section here would be 90. So I could say 90 minus 25 and get 65 degrees left for my reference angle. Okay, so now that we have identified how to find a reference angle, we now want to look at how we actually use that idea of a reference angle. So knowing a reference angle gives us an easier way to evaluate a trig function. In order to do this, and our first problem looks like cosine 7 pi over 6, I need to basically have two pieces of information. The first thing I need to know is what the reference angle is, and we've just talked about how to find that. We'll do it in just a second. And the second thing I need to know is what the sign, whether it's positive or negative, of the trig function is in the particular quadrant. So in order to do that, I'm going to jot at the top of my page here a couple of charts that we can use. All right, so the first chart is going to work for the sine function and also for the cosecant function. And we're going to draw our chart like this. What this means is that if you have an angle in the first quadrant and you take the sine of it, that the answer should be positive. If you have an angle in, say, the third quadrant and you take the sine of it, that the answer should be negative. Okay, and that also holds for a cosecant, because remember that a cosecant is the reciprocal of the sine. All right, I'm going to do a chart for the cosine and for the secant. And that chart is going to look like this. Again, meaning that if you have an angle, say, in the second quadrant and you're taking the cosine of it, that the answer should be negative. Or if you have an angle in the fourth quadrant and you're taking the secant of it, the answer should be positive. And then finally, for tangent and for cotangent, your chart is going to look like this, meaning the answers will be positive in the first and the third quadrant and negative in the second and the fourth. All right, so let's start with our first problem, part A. Okay, so the first thing that I need to do is, if my angle is 7 pi over 6, I need to know what is the reference angle for 7 pi over 6. And so we're going to approach this just like we did in the previous examples. We're going to draw our angle for 7 pi over 6. Again, multiples of pi over 6. So pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6 is right here. Okay, so that's 7 pi over 6. Remember that this line here was 6 pi over 6. Your reference angle is going to lie in between those two. And so your reference angle is going to be the difference between 7 pi over 6 and 6 pi over 6. Subtracting those would give you a pi over 6 for your reference angle. Okay? The second thing you need to know is what is the sine, S-I-G-N, of cosine 7 pi over 6. So 7 pi over 6, remember, was in the third quadrant. Remember where your angle lied. Your angle was right here. So quadrant 3, and we're talking about a cosine. So we'll go to our chart. For a cosine in the third quadrant, we see that the answer is supposed to be negative. So I'm going to remind myself that it's a negative. Now, the idea behind the reference angle is that your original problem, which is cosine 7 pi over 6, should equal the cosine of the reference angle with respect to the sign, the positive or the negative. All right, so we need to remind ourselves what cosine pi over 6 is. And we remind ourselves from our previous section that cosine pi over 6 is going to equal square root of 3 over 2. And so this tells us that cosine 7 pi over 6 will also equal square root of 3 over 2 but we know that it's supposed to be negative. And so we'll put the negative on and then be done with that problem. Okay, so looking at our last problem, tangent negative 225, we'll start the same way, and we will draw out the angle for negative 225. Remember, negative means it's going to rotate down. So we have negative 90, negative 180, and you can see I need to go an additional 45, which is going to put me right in the middle of that second quadrant. All right, so the same two questions need to be asked. First of all, we need to know what is the reference angle for this negative 225. Remember that your reference angle goes from the terminal side to the x-axis. And so what is that distance? Well, we know that we were at 180 before we moved up. So the difference between 180 and 225 is 45 degrees. So our reference angle is going to be 45 degrees. We also need to know what is the sine of tangent in quadrant 2. And so for that, we go back and we look at our chart for tangent. Remember, our chart for tangent looks like this. And so in quadrant 2, it's supposed to be negative. So we know that our final answer will have a negative on it. Now, in terms of what the reference angle tells us, remember that we now know that the tangent of our original problem, which would be negative 225, is going to be the same thing as the tangent of the reference angle. And we know from our previous section that the tangent of 45 is equal to 1. So what that tells me then is that tangent of negative 225 is equal to 1. But we know that it's supposed to have a negative sign. So we'll put the negative on and complete that second problem. So again, the reference angles can help you identify the trig functions for other angles other than 30, 45, and 60. You have to know the reference angle, and you also have to know the sign that goes with the original problem in order to have the correct answer.